Okay, this is the energy section of the matter and energy review. The matter is a different video in case you haven't seen it. This is the energy portion. You're going to need your reference tables. You're going to need a calculator. In an experiment using a calorimeter, the following data were obtained. Okay, what is the total number of calories absorbed by the water? So notice it asks for calories instead of joules, so we're going to have to do some conversions later. So Q equals MC delta T. So the calorimeter plus water is 150. Calorimeter is 100. So the mass of the water is 50. Point. Specific heat of water. Remember, that's on reference table B, so 4.18. T final minus T initial. So we got to do T final is 55 minus 25, so that's going to be 30. So get my calculator here. So 50 times 4.18 times 30 gives me 6720 joules. So then I would need to know that 4.18 joules are in 1 calorie. So 6270 divided by 4.18 gives me 1500, which is choice 3. That's a nasty question. I'm going to hopefully try to only include up to joules, but if I don't, there it is. In which of the samples is the average kinetic energy of particles the greatest? Average kinetic energy is equal to temperature. So which of these is at the highest temperature? I don't even need to look at any of this. Okay? I don't. But even if you did, it just matters temperature. As electrical energy is converted into heat energy, the total amount of energy in the system should remain the same. Energy cannot be created or destroyed, although it changes forms. An 80-gram sample of water at 10 degrees Celsius absorbs 1680 joules of heat. What is the final temperature of water? So I'm going to do that over here. So we have 1680 equals mass times specific heat times, we're looking for T final minus 10. Okay, so I'm going to do 80 times 4.18. It's going to be 334.4 times the quantity TF minus 10 equals 1680. Divide both sides by 334.4. 334.4. So 1680 divided by 334.4. And you're going to get 5.02, a whole bunch of stuff, equals TF minus 10. Add 10 to both sides. So we're going to have 15 something. And that's our answer. Remember that delta T is equal to T final minus T initial. So if you ever need to find final or initial, you just need to substitute that definition in. What is the total number of joules of heat energy absorbed by 15 grams of water when it's heated from 30 to 40? So looking for joules, Q equals mass times specific heat, T final minus T initial, 10. So 15 times 4.18 times 10, 627. Okay, so 627 is not provided here, so I look for an answer that is super close, possibly rounded to 2 sig figs, which is choice 4. Which kind of energy is stored within a chemical substance? Stored energy is potential energy. Which phase change results in the release of energy? So release of energy is exothermic. So when ice becomes liquid water, that is absorbing energy. When solid ice becomes gaseous water vapor, nope, have to take energy in. Liquid water becomes gas, we have to absorb energy. So the only one going opposite is our answer. So I know solid to liquid to gas, we're having to absorb. Gas to liquid to solid, or this way, or this way. These are exo. Okay? Oops, too far. Which graph best shows the relationship between Kelvin temperature and average kinetic energy? Average kinetic energy is temperature. So as one goes up, the other goes up. So be careful not to choose choice 3. The answer is 1. because if it was choice 3, that shows temperature increasing as average kinetic energy stays the same. So don't be tempted by that. At which temperature would atoms of helium gas sample have the greatest average kinetic energy? So again, we're looking for temperature. But here's the problem. We're dealing with apples and oranges. We're dealing with Celsius and Kelvin. So I'm going to add 273 to 25, and I'm going to get 298. And I'm going to add 273 and get 310. Now that I have 4 temperatures in the same scale, it's easy to see that it's choice 2. Burning a log on the campfire is an exothermic process. Which of the following would be an appropriate estimate for the amount of heat given off Q? So joules are teeny tiny, so I'm going to go with the largest. It's kind of a weird question, but it would probably even be more than that, but it would definitely not be half a joule or a quarter of a joule or even 10. Temperature of a sample changes from 10 degrees to Celsius to 20 degrees Celsius. How many Kelvin does the temperature change? So this is a tricky one. So if I said 10 degrees Celsius plus 273 is 283, and 20 plus 273 is 293. What's the temperature change? It's 10. Be careful. It's not asking what is this change in Kelvin, because that change would be, just 10 to 270 plus 273. But the change in Kelvin is different than how many Kelvin does it change. So it is 10. That's a tricky one. People get that wrong all the time. What occurs when a 35-gram aluminum cube at 100 degrees Celsius is placed in 90 grams of water at 25 degrees Celsius in an insulated cup? Heat flows from hot to cold. So who's hotter? So the aluminum is at 100, water's at 25. So heat is transferred from the aluminum to the water, and the temperature of the water would increase. So that's choice 2. When 200 grams of water, okay, so we got Q equals MC delta T. So Q equals 200, 4.18, remember, that's on reference table B, 50 to 25. So normally it would be T final minus T initial, and you get a negative value. The way we get around it is it says released. So that's how they get around it by, not saying negative value. So the change is 25. So 200 times 4.18 times 25 is 20900 joules. That is not an answer here. But guess what? Kilojoules. This would be 20.9 kilojoules. So that's our answer. Tricky. When a battery is in use, stored chemical energy is first changed to. Okay, well, in a flashlight where you want electricity, and that electricity is going to create the light energy. So not create, but change forms into. Which term is defined as a measure of the average kinetic energy? We just talked about this, temperature. Which quantity of electricity is converted to heat? When a quantity of electricity is converted to heat, the heat energy produced is measured in joules. Which term represents a form of energy? So be careful. Some of these are units, but some of these are actual forms of energy, which is this. Okay, 17 is one. 2 samples of gold have different temperatures, are placed in contact with one another. Heat will flow spontaneously from a sample of gold at 60, hot to cold. So we have to go something colder than 60, which is 50. Which Kelvin is equal to negative 73. So Kelvin equals negative 73 plus 273. Go ahead and do that. And you get 200 Kelvin, which is exothermic, which gives off heat. So gas to liquid to solid. So number 2. Which unit is used to express the energy absorbed or released during a chemical reaction? So energy is measured in joules. That's a 2. Sorry, make it look nicer. Kelvin is temperature. Torr is pressure. Volt is something like, I don't even really know. Voltage. Electricity, I guess. Mass. Okay, I saw that. I read the question so fast, but I know it's Q equals MC delta T. But we're looking for mass. 420 equals M times, it's water, so 4.18 times T final minus T initial, so 10. So 4.18 times 10 is 41.8. times mass, divide 420 by 41.8, and you get 10 point blah, blah, blah. So there's that. Solid A is at 80, immersed in liquid B at 60. How is the heat going to change? So hot to cold, so solid A is going to give off heat. B will absorb heat. Choice 1. Object A is at 40 and object B is at 80. Which will the heat flow? Heat flows from hot to cold, so from B to A. Sorry, it's not going to flow in both directions. No, hot to cold, always. What is the total amount of heat energy in joules? Okay, so this time they're not multiple choice, so we just have to figure it out. So 25, that's a 2, goodness gracious. 25, 4.18, T final minus T initial. And so 36 minus 24 is 12. So 25 times 4.18 times 12 gives me 1254. Let's talk sig figs. So 3 sig figs, 3 sig figs, 3 sig figs. Here they are. So my final answer becomes 125. Put a 0 in there to hold the place value. Final question. When NaCl, of course, given the equation for dissolving sodium chloride, okay, so we have the solid dissolving in water, becoming aqueous, dissolved in water, ions. When it's added to a 250 milliliter beaker, the temperature of the mixture is lower than the original temperature of the water. Describe this observation in terms of heat flow. So you can say heat flows from hot to cold. So the heat was given off by the water to the salt. You can also say that the salt absorbed heat from the water. So make sure you talk about heat flow, and so I did, and we're good. If you have any questions, please let me know. Thank you.